Okay, so we are on page 180. This is Integrated Math 2, and we're doing homework problem 17. So I want to give you guys some hints. I have 5 minutes to do this, so we'll see how far we can get. All right, so we're given that QT is perpendicular to PR. That means that this line is perpendicular to this line, which actually we can see right there. It's marked it with a right angle. QT bisects PR, right? So if I marked a little line, I could say that this line and this line were congruent, right? And then it says that QT bisects VQS. So VQS is this internal angle here. That means, and I'm just going to put a dot instead. I'm going to say this angle and this angle are congruent, okay? So what we're looking to prove is that VQ is congruent to SQ. I'm going to grab some green and say that VQ, that's this internal line right here, is congruent to this internal line right there. All right? So what I need to do is I need to find a triangle which contains that. So we see right here that this triangle, I can draw that triangle. So this little triangle right here and that little triangle right there, those two both contain, those contain the VQ. All right, so that's helpful, but it doesn't tell us what exactly is going on. So if I labeled that, that would be P, Q, and this is R, and this is Q, and this is V. Put a little line for Q, and this is S. Okay, so if we looked at that, what we already know is we know that this line is congruent with this line. And by process of elimination, we know that this Q, again, I'm just going to put a little dot, this Q, because this comes to 90 degrees and these two are congruent, so that means those two also, they're complementary angles. So that's congruent as well. However, we don't have a theorem that says side and angle. We're going to need one more thing. So what we're going to do is we're going to look at a triangle outside of that. If we look at this triangle, PQT, I will try to draw that in my best skill set. P, Q, and T. What we see is that we could compare that to RQT. Again, I'll draw it in my very best perfect right angle triangles. And what we have is we have that these are congruent, right? We already know that. We have that this line is congruent, QT is congruent with QT by our reflexive angles, or reflexive lines, right? They're the same line. And we know that this angle is congruent because they're both 90-degree angles, because that was part of the proof. So we can use a theorem there, and I'll let you figure out which theorem it's going to be that's going to go there. So once we have that, we know that P and R are now part of these congruent figures, right? Congruent parts of congruent figures. I'm going to label this for you so that you know what I'm talking about. I'm going to put a big Q in the center because I think you can figure it out. All right. So if we know that, I bet that you can then go and say, well, if P and R are congruent, I definitely have a theorem with two angles and one side. And you should be able to solve that and come up with the answer of why those two are congruent.